the levers on the sides. Here, I'll come over and help you out. So unless you emailed me like this morning, actually there's maybe one email. I think somebody in this class actually emailed me on Friday or something. So I should actually probably change what that says to unless you emailed me post Thursday. If you've emailed me since Thursday, I probably need to check it and update some grades. Aside from that, I believe that map is pretty much up to date. New stuff is due Friday, and that's going to relate to today's lesson and Wednesday's lesson. We are going to have an actual mastery on just inequalities. Well, actually, probably equations and inequalities next week when we're all back in person. So then I can grade it over spring break. It will probably be a little bit longer because we'll be at school every day. So I don't have to make it just like a 3 or 4 question one. It can be kind of more comprehensive. We got to end that unit because as of today, we're completely starting a whole new unit. So if you have all of your notes from equations and inequalities and everything else, like you could group them up and throw a paper clip on them or something like that, but keep them because I'm going to collect those probably next week when we're all back together in person and we can do things a little bit easier because we'll all be together. Question or just playing with hair? Put 2 people at each one of those plastic chairs and that many. My room is set up how it needs to be, except for those desks will have 2 people at them. So they'll scooch in from the wall a little bit. Depends on the class. Your guys' class, 1A, currently should have 9 people in here right now, and there are another 10 for green, so we'll have 10 more people in here. So we won't be totally full. My room can fit 23. We'll only have 19. So we'll still have some desks open.
Well, do we have school Friday, or is it...
This Friday? No. Green. Green until we're back, all in person. All right, so go ahead and get your notes out. Please make sure your name and date is on them. As we discussed, yesterday was Pi Day. Happy Pi Day, everyone. So today is 3/15. And because yesterday was Pi Day and the world likes to smile on us every now and then, timing worked out that today we get to start circles. Yeah.
I just realized why March 14th was Pi Day, because 0.14.
Yeah, so let's talk about that. Pi, and I guess I probably should have put that on here, right? Pi, as Lacey just pointed out, I didn't even realize that I should probably talk about this. Pi is 3.14 when we approximate or round it, which is why March 14th gets celebrated as Pi Day. So if you did anything involving circles yesterday, you can thank Pi for making circles possible. Pi is mathematically written as the symbol that looks like a dude with wavy arms. I don't know why my focus can't figure itself out today. Give me a second. Coming back. There we go. All right. I think it does not like my printout of circles over there. Yeah. Yeah, a lot of music symbols and math symbols are kind of similar to each other. All right, so can anyone tell me what the radius of a circle is, how we describe it? It's the line that dances?
Yes.
Karate line?
Yes.
We got to use words, right? So up here, if we grab our highlighter, every circle has a center. Please come over here and make sure that we notate that this dot in the very middle of the circle is our center. And that point lies, well, at the center. Fun thing is, that's how people can spin plates. You know where the center is, guys? That's the center of weight, too. So actually, if you find the center of a circle, you should be able to balance a perfect circle. Now, pottery is often not perfect because it's handmade. A perfect circle would balance from the center. Yeah, Lacey?
So, isn't the radius like the distance from the from the side to the center?
Ah, yes. So, a circle is a shape where the distance from the center to the edge, the distance from the center to the edge, that is our radius. And all of them are identical, and there are technically infinitely many of them. So please write beside radius, line, and you can call it distance too if you want, but line is quicker to write. Line from center, bless you, to edge. And the edge of the circle is, of course, the edge. Nothing fancy about that. Now the diameter, now if you're looking ahead in your notes, you can probably already figure these things out. The diameter,
pretty much, it's like the distance from the edge to the edge that's like straight across, kind of.
yeah, it's put two radiuses together, go straight across. So it is the line across the circle through the center. So it is the line across the whole circle through the center. So if we come down here and want to highlight, in the next circle, ooh, that's really dark. My bad. Yeah, sorry, I highlighted the word diameter in purple, but now you can barely see it. Diameter, right? Meter, like to measure. So D-I-A, diameter. And then circumference.
Circle.
Ooh, circum means around. So guys, let's go ahead and first remind ourselves that circum, we know, means around. Circum means around. We had a STEM study where we learned that. And, well, ference, kind of ignore the FER, but like, well, I don't know. This is always where I kind of make this up. And not like make it up. But like, anytime we have like ents, like, it's often talking about some sort of measure. And here, anyone know what they're talking about as like some measure around?
Kind of the perimeter almost?
Yeah, it's the perimeter of the circle. That's absolutely what it is. So we can go ahead and say this is and now we can put it in quotes because perimeter normally means like every side added up.
But there's not really sides to a circle.
Yeah, so if we highlight it, right, if we have our highlighters that we should have, at least 3, we normally say 3 colors is pretty safe. We can highlight the distance round. We can say if you take 1 lap of that circle, that's going to be your circumference, the distance around. Now, we do have formulas for these things, or equations, or little shortcuts to find them. Our diameter, and guys, I don't care where you write this, I'm going to write it over here in the circle. Our diameter is 2 of the radius, right? Because we can see that, right? Our diameter is 2 of the radius.
And isn't it like the radius times something like pi?
Isn't it the radius times something is what every person says about circles. Which is why I like chuckled. I promise I'm not laughing at you. I'm laughing with you. Because anytime people are like circles, they're like radius, pi, something. Something with radius and pi, and you're absolutely right. So guys, here's my saying over here that I want you to take a look at. Crust is pi dough. This is not my saying. I stole it from Danica McKellar, sorry, who is a Hallmark actress and a mathematician. Actually, I have books of hers. In one of her videos, she talks about like little memory tricks for circles. If you eat a pie, she's actually pretty funny. If you eat a pie, the crust is made of dough. And if you eat a pizza, the crust is made of dough. Well, guys, crust is pi dough. Crust is pi times d.
Oh.
The circumference is just pi times diameter. But another formula that we could use, so I'm going to put like a little colon here, another option, is replace the d with, well, we know that d is 2r, so it could also be pi times 2 times r, because 2 times r is diameter. So there are lots of formulas. Like if you Google search circumference formula, there's a bunch. But these are our two main ones that we're going to start with, is if we know the diameter or if we know the radius. And guys, really, if we know the radius or the diameter, we can figure out the other one. If we know either of them, then we can calculate the circumference. Actually, same story with area of the circle, but we're going to get to that on the back. So take a moment. I want you to try these 3 problems on your own. I mean, I guess I'll start the first one with you. We'll do the first one together. Lacey, question?
Would, like, if you have a circumference to find the diameter, or to find the diameter,
We got to work it backwards.
Yeah.
It gets tough. So we'll get to those problems, but those are kind of more the challenge problems. That's literally, Lacey, if you want to challenge yourself, back bottom. If you flip to the back bottom of the notes, there's a challenge problem there for you.
Oh, yeah, I see it. Yeah.
So right here in the middle, oh, sorry, and yours has little boxes around this because I realized I should box these in. So yours looks better than mine does. If the radius of a circle was 3, well, the radius would be this center to the edge, right? If that was 3, what would be the diameter? Well, we said diameter is distance all the way across. Another thing we said was, well, diameter is 2 times the radius. So this would be 2 times 3. Oh, okay, diameter would be 6. Try the next 2 on your own. Actually, and try the circles on your own down here as well. Let's do one of these together. Then I'll give you like a few minutes to do all 4 of these. So let's do this first one together, this 18. Guys, what is that 18? Actually, I should use cards here, really. That's not this class. Isaiah, what is that 18? Of course he's not. Lily? It is the diameter, right? They are showing me the distance all the way across the circle. So guys, go ahead and label that. That's your D. Which means, Martin, what else can we figure out if we know the diameter is 18? Yeah, the radius is 9. So guys, go ahead and draw a little line that doesn't have to be perfect, but that you would think kind of splits this up. And we can label that 9. And of course, that would be centimeters. Sorry, I should have written that a little differently. And then we can use our circumference formula of pi times diameter. Well, so either I could do pi times 18, or guys, we could actually write 18 pi, or another formula we could have used would have been pi times 2 times the radius, but that seems a little silly here. But when we calculate what this actually comes out to be using your calculator, guys, if you don't have a calculator, get one. If you don't have a calculator at your desk, get your booty up and walk to the front. Get a calculator for yourself. So, Mr. Hudson will quit singing. Guys, on your calculator, this gets real tricky. Because you have options. Martin's really mad today. He's just going to throw the calculator back to his desk. I don't want to get a calculator. So check it. On your calculator, there is a pi. Ooh, hey, look, pi. But we also get told pi is 3.14. But notice, if I hit pi, it knows more than just 3.14. So if you want a more precise answer, use the pi button. If you want to just use the rounded answer, which most of the time people don't care about, use 3.14. Try it both ways. If I type in 18 pi versus 18 times 3.14, do we get a substantially different answer?
Yeah. Oh, no.
I mean, it's different at the hundredths place, right? it's already different at the hundredths place, I think that's kind of substantial. Like, I can already see the difference only going 2 decimal places when given the option, my personal opinion and preference for you, use exact pi. If we're using a calculator, guys, it's easier. Lily just like made a face at me for saying use exact pi. It's easier. It doesn't matter. It's easier to type in. Literally, type in your diameter amount, hit the pi button. Now, if your calculator's being dumb and doesn't give you a decimal answer and instead gives you back 18 pi, we need to go change the mode to classic. Right? We talked about this the other day. If your mode is in math print, your answers will be coming out in forms of pi, which gets frustrating when you're like, I want the decimal. We need to go change it to classic mode.
It took me a while to find the pi button, but I found it.
Yeah, it's here on the left-hand side. So try these other 4 on your own.
It's not on the left.
You have a different calculator. Also in your math menu. If you're ever looking for something, if you just click math, the math menu has most of those things.
Yeah, but oh, there we go. Right here.
Nice. Yeah, then you had to go switch your mode.
I don't know how to switch the mode.
Which calc are you using? One like me?
No,
So Natalie, you should really just use one of mine. And really, like, if you need to borrow it, you can, or I can hook you up with another one that you could use. I don't know how to work your calculator, and we're going to keep having these issues of your calculator being different than everyone else's.
is my calculator fine?
Yours is still a TI, so it's more similar to this one. Yours is fine. It's just a Casio. Those have more financial things. So like when Natalie's computing how, people's books and figuring out what people need to pay the IRS and whatever, that calculator would be perfect. On this calculator, this button, Nate, don't do it for her because then she won't learn anything. Right here. Now, what kind of calculator do you got? Hold it up. Do you got one of these? Oh, you should just get one of mine.
I pressed mode and then it's weird.
So I don't know how to fix your calculator, and this is one thing that I am going to be like kind of meanie teacher about. This is the calculator that was on the supply list. So if you don't have one of these, like we're not going to spend a bunch of class time figuring it out. Your parents got to help you figure that out. Or come to me at AOR Extensions, but we got to keep moving for class time. So if we round to the hundredths now, it's really like 56.55 if we round it. Now, be careful. That label needs to be there, right? It's still the same distance label as whatever the distance of your diameter or your radius was. So you still do need that distance label of whatever the units are. So actually up here when we calculated diameter, I really needed to go ahead and put units. So guys, take a minute. You can move to the back if you want, but you are doing these next 4 on your own. Ooh, careful. This last one up here says diameter. All right, Natalie, in this middle one up here, if the radius of a circle was 8, its diameter would be? Yeah, absolutely. We double it. Now, make sure we grab those units. Here it's kind of lame. They just say units, but label it units. You can just put U, honestly, if you want. Yeah, that's fine. Lacey, if the diameter here is 10, diameter here is 10, the radius.
The radius is 5.
Yeah, this one we have to half it.
Yeah.
Right, so that one's 5. Nate, down here, if this is 7, what is it and what else can we figure out? What is the 7? Is it radius or diameter? Yeah, it's the whole distance across. That is the diameter. So Nate, if you need to, here in your picture, put a D equals over to it. So then, how do we find the radius if we have the diameter? Careful, you don't just listen to what people say. If it might help you, go back up to the top of your notes and make a little note by radius. That radius is the diameter divided by 2. When we are looking to find the radius, it is the diameter divided by 2. So down here, if we have the diameter is 7, we divide that by 2. And we say the radius will be, 7 divided by 2 is, if we like decimals, which I guess most people do, 3.5. Now our circumference, guys, I would draw a line here if I was you to keep your problem split up. Our circumference formula is just pi times diameter. So luckily our diameter is a whole number. I'm going to turn around the order of my multiplication and say it's 7 pi. But when we put that into our calculator, we will get a decimal answer of 21.99. And that will still be centimeters. Questions on that? No, because, I mean, we could if I was rounding, like, at the tenths place, then yes, it would. But with me wanting to round at the hundredths, because normally we go 2 decimal places, the next number's a 1, and that says stay where you are, right? That's don't go up, stay where you're at. Sydney, over here, this 4.2 is our, so our diameter is, 8.4 centimeters. We should make sure we label. Which means, Stella, when we go to calculate our circumference, yeah, so it'd be 8.4 times our pi, right? And then you said it's what, 26? Any questions on the front of our worksheet? The back only layers on one more thing. We're just putting the icing on the cake. We got the cake layered up now. All the fruit filling, all the the thing around the outside, the something dam, to keep your fruit from running out. Does no one watch baking shows here?
I don't know what the worst cooks.
Okay, I like Worst Cooks too, but I gotta learn something. Actually, Worst Cooks is good for learning stuff too. Except I can't hold my knife how they want you to. It hurts my hand. They're too, like, serious for me. Well, okay, I should probably watch it again. I only watched it once, and I got scared. Yeah, don't do that. Yeah. So, guys, speaking of baking, sorry, this was a segue. I can't let us go too far from the past. Speaking of baking, let's say we take a cake, a pie, a pizza, whatever you want to bake, and bake a circular object. But like all pizza places, for some reason, we have square containers, square boxes, rectangular leftover containers, right? Like rectangular sandwich bags, right? Like nothing else is really circular. So I take my pie, my cake, my whatever, and I slice it up, right? If we count the amount of slices here, we have 1, 2, 3, 4, 5, 6, 7, 8 gray slices, and the same of the light colored slices, right? 1, 2, 3, 4, 5, 6, 7, 8. So we come down here, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7. Ooh, crap. On the end, we have to cut these, or else it'll be more of a trapezoid, or sorry, it'll be more of a parallelogram than it would be a rectangle. So if I didn't cut my final slice, it would be, sorry, I need my pencil. I already pulled it out this morning. It would stick out over here, right, if I didn't cut this. So I cut this one in half. You with me? Yeah. I can rearrange my round thing I just baked into a rectangular, relatively rectangular object pretty cleanly. The only thing keeping this from being a rectangle is these tiny little dimples, right, from the edge of the circle. But actually, if we average them out, I could trim the tiniest part off the tip of the dimple, like the curve, the bump out, and just kind of shove it into here, right? So if we imagine this is our icing's just going to squish, right? Like it'll squish. I can make a rectangle out of this. So really, the area of a circle we could talk about as, I don't think I've used blue today, as a rectangle. Well, the rectangle's area would just be length, okay? So pi times r times width, right? Rectangle's area is length times width. That's our circle area. Because our circle area is technically, sorry, I should pull the extra copy out from under here. Pi times the radius value squared, which is not 2r. This is the trap door, guys. This is not 2r. This is not diameter. This is a different equation. Yes. This looks so similar, because, guys, circumference, I need a note card. I lost all my note cards. Guys, check it. Circumference is pi times radius times 2. Pi r2, pi r2. They're like the same. This is really, really a dangerous trapdoor. So please remember, circumference is times 2. Area is squared. So that's why down here we're going to practice finding both circumference and area to help you practice avoiding that trap door. So we already kind of talked about using exact pi versus 3.14. It's easier to use exact pi, right? On con, this is the section that I wanted to talk about with what con says. Either enter an exact answer in terms of pi. Ooh, wait, in terms of pi. Everyone highlight in terms of pi. Guys, if we are going to enter our answer as a decimal, and this is the note in con, this note actually means we can't use the pi button. Because if we're giving a decimal answer, they tell us use 3.14. Because of the issues with rounding created by exact pi. It actually creates problems for computers. Because, like, are we using rounded pi or exact pi? So, check it out. If the radius was 8, here's how we're going to do this work. we are going to say the area, we're just going to practice finding area on this one, then for the next ones we'll find multiple things. Area is pi times radius squared. So, it's pi times 8 squared. We know 8 squared. What's 8 times 8? 64. 64 pi. They don't give us a unit. I guess that's dumb. They normally give us a unit. Our area is 64 pi units squared. This is in terms of pi. This number using, this is going to smudge all this. This number using the actual pi symbol. Sorry, this is my pi symbol. So guys, this is 64 pi. But our other option is to take that 64 pi and turn it into 64 times 3.14. Not using the pi button, but using the value that we all agree is pi, because it's approximated. So again, it's not the exact value. And that would get us 200.96 units squared. Both of those answers are absolutely fine. It's just whether we want to use 3.14 for pi, which then gets us this as our answer.
When you were up on the picture, you said parallelogram. I can't say the parallelogram like that. I always say it like parallelogram.
Yeah, add too much. Like when people say schoolology. Yeah, it's schoology. School OG. That's it. All right, so try the next three on your own. Notice it's asking us to determine the radius, diameter, and circumference, and area. So actually, guys, a lot of this information we could write up in the circle if you want. Like, you could definitely write the diameter in the circle. We could probably write the circumference just beside the circle. You don't have to do all this beneath of it. I would maybe save the beneath spot for the area work. I'm going to just draw some lines to separate my page first. Let's say 5 minutes independent. 5 minutes, you guys working independent. You can talk with each other. I don't care. Independent just means without me. Where'd my timer go? There we go. Ooh, I used this one, the radius of 7, by the way, just to point out that over here on the front, this was diameter of 7. This is a different circle, right? This is radius of 7. So be careful. It's not the same circle. I know when kids are like, wait, we did this one already. Not quite.
Almost.
So we should all be trying this on our own, using our calculator.
Did I get a ruler?
Absolutely. Yeah, they're up by the highlighters.
Where are they?
In the little plastic tote. To the left of the calculators. Look to your left, to your left, to your left. By the highlighters. See all the highlighters? There you go. Well, they're all real close to each other up there. So guys, just like area can be left in terms of pi, if they tell you that circumference can be left in terms of pi, it could. We could just, so for this first one here, we could say circumference is 2 pi. But if they say that we have to write it as a decimal, if we use 3.14, now I promise I will actually be quiet. If you need help, there's the first one done out for you, and I still need to do area. But yeah. Guys, even though we often say pi times radius squared, we often write the radius squared first. So please don't get confused when I switch the order. Remember, multiplication's order can be switched around and it does not change anything.
What is area again?
Area is how much space something takes up. So again, like, thank you for that question, but up here we were showing like darkly shaded and lightly shaded. So this is where using black and white print is a pain in the butt. This was really yellow and blue. And sorry, I know, Michigan colors, oh no. But this was really yellow and blue, so I should have shown you guys this. These are all colored like to be shaded. So maybe this is like a cake that you made for Michigan's day that they always lose to Ohio State, and maybe they celebrate that day every year. Maybe they celebrate we lost to the state down south. Yeah, so Michigan and Ohio State have this like rivalry, but Michigan never beats us, so it's kind of a dumb rivalry. I mean, if we did that, we would probably get a penalty. So.
Especially Michigan.
Wait, hold on. If this is pi units squared, that means our area is 3.14 units squared. So our area is less than our circumference. It's apples and oranges. And if you've never heard that statement, what that means is it's not comparable. You can't say, I have 5 apples, well, I have 5 oranges. It's like, well, I don't care. I want apples. Like, guys, units, this is distance versus units squared. These are not really comparable numbers. So you can't really say 6.28 is bigger than 3.14 because they have different units. So 3.14 is how much space the circle is taking up on the inside. 6.28 would be the distance around the outside. Lily, for our next one, if we have a radius of 7 given to us, then what would that diameter be? 14. And we can call it units. Since it didn't give us a label, we can just call it units. Which means our circumference, if we could leave it in terms of pi, just 14 pi. Or if we compute it, did you compute it already? What'd you get? Yeah, 43.96, I think is what I got. I couldn't hear you on that last decimal place. And of course that would just be units. Did you use 3.14, right? They told us if we're going to calculate it, we need to use 3.14.
Yes, I did.
So it should be 43.96.
Okay, I accidentally used that.
Yeah.
43.98.
See, so be careful. Look at what they say on Khan. If they let you put your answer in terms of pi, just put it in terms of pi. It's easier. So guys, this is using exact pi. Like, even if once we punch it in the calculator, it's going to round it. It's not exact anymore. This is exact. So our area I'm going to go ahead and just write it r squared times pi, because we can change that order on our own. And r squared is going to be 7 squared times pi. So areas, what's 7 squared? 49 units squared. Ooh, wait, not just 49. 49 pi, right? This would be 49 pi units squared. Or, if we use our calculator, 49 times 3.14. Guys, this is stuff that I do not expect you to, like, even try to do in your head. It's just silly to spend the time trying to do that.
I got 153.94 units squared.
Did you use your pi button again? Because I think you did. You're going to have a problem with that. But you could just leave it as 49 pi, Lacey. Like, you don't need to calculate it as a decimal. But if we use rounded pi, we get 153.86 units squared. Martin, if our diameter over here is 10, what do we know? The radius is 5, meaning our circumference could either be 10 times pi. Ooh, 10's nice. Or 31.4, right, if we round it. Now our area, careful, we're not using the 10, we're using the 5. Right, we're using the radius, not the diameter. So radius squared times pi. Could, yeah, be careful. Could either be 25 pi or, all right, unit squared. Or if we calculate it, yeah, 78.5 units squared. You guys got a couple minutes to try out these challenge problems while I come around with wipes. If you're given the circumference, are you able to work backwards to find the radius? Well, I'll tell you, you are able to. The question is, can you rise to this challenge? Are you able to work it backwards to find your radius? Just a little bit of algebra, right? A little bit of do the same thing on both sides. So and then once we have our radius, then we can calculate the area. We're going to start with those problems tomorrow. No, we're not going to start with those problems tomorrow?
Wednesday. No, thank you.
Well, okay, that is tomorrow for you guys.
No, it's not. Tomorrow's Tuesday. Tomorrow's Wednesday.
But tomorrow's school day. Tomorrow's school day is.
How are you? I'm gonna try to work it out. I'm gonna try to work it. Well, we still have to do work on an off day. I think